This hour will cover some topics about wired network, which is Ethernet, and some um, devices at different layers, and how they connected to with each other to form network. Okay, so the first topic is Ethernet. Um, Ethernet, we say is a de facto standard of wired LAN technology. So um, it is it is the first widely used LAN technology. Of course, there were several different LAN technology, but we don't use them anymore, like Apple Talk, like IPX. But currently, we only use Ethernet, and of course, Ethernet has different versions. You can use twist paired copper wire, and of course, you can use fiber to run Ethernet. Of course, there are some different variation of Ethernet. Okay, so we have 10 megabit per second Ethernet, and we have 400 gigabit per second Ethernet. Of course, it runs on the top of fiber. It is simple. It is very cheap, and we have a figure right here. It was the very first concept of Ethernet. The yellow cable right here is the main cable, and it's very similar to cable modem we have talked about in the first chapter. Usually, there will be several network interface card, okay, which their interface cable connected to the main table, okay, which is the yellow one right here. Usually we use this word tap, TAP, to describe it is connected to the main cable. And of course, on the main cable, there could be lots of interface cable, and there will be lots of interfaces. Okay, and when one of the interface, okay, it send a signal out, and all the other interfaces on the cable, in the main cable, can hear the signal sent by the sender. So it is a shared media, and multiple interfaces would like to access the channel. So it is a multiple access problem we have talked about, right? So that is the original Ethernet. Okay. Usually, Ethernet we has two typical topologies. Okay, left hand side is the bus. Okay, it's very similar to the figure which I showed in the previous page, right? We have a main cable right here and a lot of interface cable connected to the main cable. So this is a shared media, and we have multiple nodes would like to access the channel, and collision happens, indeed. Okay, but such kind of topology we call it bus topology. Okay, it is very popular through mid 90s, but after that we have another layer 2 devices called switch right here. Switch is a layer 2 device. Okay, so basically the switch will help all the other interface card, okay, connected to the switch to perform broadcasting to all the other interfaces on the switch. Okay, although there will be several interfaces, okay, between the switch and the connected device, okay, but this specific cable, okay, only two interfaces are on this cable. So basically, a collision would not happen. Okay, collisions, the probability of collisions is quite low. Okay, but this switch need to help for example, we have a signal from this from left hand side to the switch, and this switch has to broadcast the signal from the left hand side to all the other interfaces. Okay. Basically, currently, when you go to for example, Best Buy or Amazon, you want to buy a layer 2 device, to buy a switch. Basically, you buy switch, but you don't have any devices like bus, right? Basically, it is a switched topology. Okay, so that is okay. Let's take a look at the Ethernet frame structure. In layer 4, in layer 3, we have layer 3 headers, we have layer 4 headers, right? But in layer 2, Ethernet has header and trailer. So some of the information is append before the payload, which usually is a layer 3 diagram, okay? But some of the information has attached at the end of the layer 3 diagram, okay? The trailer is quite simple. That is the CRC, okay? That is the CRC field. So we have taught you how to calculate the CRC value, right? But basically, it is based on mathematical division, right? The header right here is still very simple, okay? We have a type right here. So basically, the layer 2 frame would encapsulate layer 3 diagram, right? But sometimes, okay, some layer 2 protocol, okay, they are not, as mentioned, they're layer 2 protocol, right? So some layer 2 information will be encapsulated right here, okay? And as we mentioned before, although we use IP diagram quite often, and basically it is the layer 3 de facto standard, but in early days we have some other layer 3 protocols which is not IP, so you have to specify what is the type of data which is encapsulated by this Ethernet frame, and we will show you some different packet, okay, next time. And of course, as we mentioned before, we have layer 4 interface address, okay, which is a MAC address. So we have destination address is for 84 bits, and we have source address is 48 bits as well. Okay, I think the most important things right here is the preamble. Okay, basically it is not actual data field. Okay. It is used to synchronize the receiver and the sender's clock rate, because when we talk about CSMA-CD, okay, Ethernet, basically the protocol runs like that. A sender will sense the channel, right? Sense the channel. If the channel is idle, the sender will directly send signal on the channel, right? So as a receiver, when you basically you will listen to those signals, right? But basically, because Ethernet is not slotted, okay, so you don't know when the sender will send a frame, send the first bit of a frame, right? So basically you have to listen to the channel very carefully. But sometimes maybe there's something wrong, so you have to make sure you hear the very first bit, right? But sometimes, due to some reason, okay, maybe the noise, maybe due to the noise, maybe there's some problems. So you need to synchronize your clock, receiver's clock and the sender's clock. So basically, we have 8 bytes right here, which is the preamble. Okay, 7 bytes are 10101010, and the last 1 byte is 10101011. So as a receiver, if there's a signal and you hear the signal, okay, you have some time to synchronize your receiving clock with these 8 byte. In total, there will be 64 bits, right? So you keep counting 1 0 1 0 1 0 and keep up to be synchronized with the sending rate. Okay, so after you hear, as a receiver, you hear the last 2 bits are 1 and 1, and you know, okay, the next bit will be the destination address, first bit of the destination address. So you have some time to maybe we say to tune your clock, the receiving clock. Okay, that is the reason why we need preamble, because we don't know when the sender will send this frame. Okay, so preamble is not it's not actually it is not data. It is not the header field. It is used to synchronize the timer, okay, the clock rate, and destination address. Okay, it is actually the first data field, okay, in your header. Okay, as we mentioned, addresses, there are 6-byte source and destination MAC address. If adapter receive a frame with matching destination MAC address, or a broadcast which is OFFF, right? Broadcast address, for example, our packet use broadcast address, and it passes data in frame to network layer protocol. We will do unpacking and pass the data payload, okay, the network layer diagram to the corresponding program, okay, in your operating system. Okay, otherwise the adapter will discard the frame because this frame is not for this specific destination address. Okay, and type right here indicate the higher layer protocol. As you mentioned, in the early days we have, for example, IPX, we have AbleTalk, we have some other layer 3 protocol, but currently we simply just use IP protocol. Okay, the CRC, the certificate redundancy check at the receiver. If the receiver, okay, usually in Ethernet, okay, again, when the sender wants to send a frame, it do carrier sense, right? So if the channel is idle, then the sender sends the signal out. Okay, when the sender sends the signal, the sender itself still need to hear if there's any collision happens, right? So if anything goes wrong, for example, if when the sender sent the frame out, okay, and it hear collision, okay, as we mentioned before, it will stop sending the rest of the frame and try to do random backoff or binary backoff, right? But if nothing happened, okay, everything is fine, then the sender will believe all the bits in the frame is successfully arrives at the receiver. Okay, so that's all. The sender will not do anything else. Okay, it's simply just here if there's any collisions. Okay, happens when the sender send the frame out. But at the receiver, okay, the receiver, okay, here would like to hear any collision on the cable, right? But if there's no collision, that's fine. But the receiver need to check the CRC value, okay? If the check is okay, then this data will be passed to the layer 3 program. But if the CRC check-in, okay, has something wrong, this frame will be dropped, and the receiver will not do anything else. This packet is simply just discarded. Okay. So right here, there are several characteristics of Ethernet. For example, the first one is connectionless. As you mentioned before, when the sender would like to send a frame out, it's simply just to carry sense. If the channel is idle and the sender directly send the frame out, okay, there is no handshaking between the sending and receiving network interface card. There will be no sing act, okay, through handshaking like what we did in TCP. There's no handshaking. And the second one is unreliable, okay. Receiving network interface card does not send any X or NEX back to the sender. So data in drop-dead frame will not recovered by Ethernet. If you want to recover your drop-dead frame, you have to use higher layer protocol such as TCP. So when your message is segmented in layer 4, so there will be a sequence number for your segment, right? And we have talked about pipeline mechanism. So if the segment is encapsulated in a diagram, right? And the diagram is encapsulated in a frame. If the frame is dropped by layer 2, there will be no any recovery mechanism at layer 2. The frame is simply just simply dropped. Okay? But at layer 4, your TCP, there will be a clock, right? And TCP, some TCP protocol, they keep monitoring 3 duplicate act, right? If 3 duplicate act is observed or the timer is triggered, and at layer 4, the segment will be retransmitted, and there will be retransmitted diagram and retransmitted frame will be transmitted in the shared media in the Ethernet. Okay, at layer 2, there will be an unreliable transfer protocol. Okay, so Ethernet's MAC address, MAC protocol is unslotted, sys-MACD. Okay, carrier sends multiple access with collision detection, and we have bandwidth backup mechanism. Okay, that is Ethernet. And of course, there are some extension and variation of Ethernet. Ethernet, its name, its name is IEEE 802.3. Okay, that is Ethernet. But there are many different Ethernet standards. Okay, and they have common MAC protocol and frame format as we showed you before, but they have different speed. Okay, 2 megabit, 10 megabit, 100 megabit, 1 gigabit, 10 megabit, 4 gigabit. Okay, and they can use different physical layer media like cable, like fiber. Okay, and of course, all those things are designed and implemented by EE students and right. So we simply just skip this slide. Okay. So I'd like to show you some materials not in our textbook. Okay. So I think maybe you need to spend some time to follow this slide. Okay. So when we talk about we have introduced lots of devices, right, and different protocols, right? But as a MIS student, okay, or a CS student, you need to use those devices and connect them together and to serve your LAN, right? To serve your PC, serve your laptop, right? You have to know how to connect those devices correctly. Okay, so let's take a look at I will draw a figure right here. Okay, so layer 3, we have routers at layer 3, right? Router is a layer 3 device. Okay, so basically in the network, you should have router like this. Okay, router is a layer 3 device, so it knows how to unpack a datagram, right? It knows IP address, destination IP address, and of course, because it is a layer 3 device, it also has some layer 2 interfaces, right? So it also knows how to send a frame on the Ethernet. Okay, and as we mentioned before, usually for a router, okay, we use this figure as an example. Okay, at the right hand side is the WAN, wide area network, which means it is the internet. Okay, so WAN for the interface card is connected to the internet, and in internet we know there are lots of different routers, right? Different routers, and those routers are connected together using different topologies, right? Something like this. Okay, so those routers runs OFPS or BGP, so they know how to do routing and forwarding. Okay, so let's assume the interface card right here. Okay, it has an IP address for just for example. Okay, it is okay. It has an interfaces right here, and it has a public IP address. Okay, 140.119.1 and 1. Okay, this is just an example. Okay, and in the internet, as we mentioned before, you should only use public IPs, right? So at the right hand side, that is the word of public IP. And the other thing is that in the enterprise or in your company, okay, you should connect more than one outgoing maybe I should draw this one more precisely like this. Okay, something like that. Okay, I believe I have mentioned about one concept called multi-home. Multi-home means, okay, you have another additional interface card which is connected to another device, another router. So even if one of your ISP, okay, for example the upper one, this link is disconnected for some reason, for example a power outage or just an earthquake or disaster, you still have another route for your enterprise. Is reachable by the internet, right? I mean this one. So it would be better for a company, for enterprise, to have two more outgoing line, okay, at your router, so that you can decrease the possibility of disconnected from the internet. Okay, and again at the left hand side, right? Left hand side. Usually, okay, we call it then, right? Okay, or your subnet. Okay, of course you can if your ISP gives you a bunch of public IP address, you can simply just set up your that network by using public IPs. But most of the time, we don't have that many IP address, public IP address, right? Because we have only limited public IP address. So basically, most of the time, okay, we in our private LAN, we in our LAN we use private IP addresses, right? But again, if you have enough money and your ISP have enough public IP address, you can buy those IP address from your ISP and you can use those public IP address in your LAN. But most of the time we use private IP address in our for example in your company. Okay, and as we mentioned before, a router may have maybe 12 or 24 or even 84, 48 ports. So a router is very expensive because it has to handle lots of traffic, right? For example, for router, okay, when you receive a layer 2 Ethernet frame, you have to unpack the frame, right? And you have to check the CRC value. You have to unpack the frame and to get the IP address. So you have to check the destination IP address against with your routing table, so you know which port this diagram should go to, and you have to encapsulate the IP diagram again by using Ethernet frame and send the frame out to the next hop, right? So router is very basic, and even sometimes router should router has some other functionality like NAT, like DHCP server, like DNS server. So router is very busy, and so a router is very expensive, and sometimes we have we should connect a router to a switch, right? So every square right is a port on the switch. Okay, we should connect the router to a switch. So you have more ports on the switch. So your for example, your PC, your for example, we have PC right here. We have PC right here. So you have more ports. Okay, can be used to connect it to the PC in your LAN. Okay, let's make assumption that in your LAN, okay, you use this IP address. Okay, you use this subnet in your LAN. Okay, and as you know, 192.168, it is a private IP address. So this IP address cannot be routed in the right-hand side public internet, right? So basically, your router should act as an NAT server, right? As we mentioned before, and in this network, it would be better to have some other very useful devices like DNS server and DHCP server. Something like that. Okay, so the routers, okay, the company get a bunch set the private IP address will be 192.168. So DHCP server will distribute those IP address to the newcomer in the private LAN. Okay, so we simply just write some random IP address on this interface card. Okay, so okay, so for the DHCP server, okay, it has a interface card and it get the IP address right here. Okay, and the green letters, okay, those are the MAC address. Okay, we simply just write some random MAC address right here to represent different interface card, okay, in this subnet. Okay, and the number I write here is the port number. Okay, this specific switch, it has 9 different ports. Okay, we simply just write down these numbers as their IP address and their MAC address. Okay, so basically at there too, you should have a switch to connect different servers or PCs together so they can communicate with each other. So for example, for PCA, okay, when it turns its power on, is this machine, okay, this interface card, green AB, it needs to get the IP address, right? So the green, so it will send a DHCP request out to the switch, right? And the switch, it's a layer 2 device, so it will broadcast this DHCP request to all the other ports. Okay, so it received the port from, it received the frame from network interface card AB. Okay, at port number 2, the switch will broadcast this frame, this DHCP frame, to all the other ports, number 1, 3, 4, 5, 6, 7, 8, and 9. And eventually, at port number 5, the DHCP server will receive such kind of DHCP request. So the frame, okay, will reach network interface card DD, and then the DHCP server, this machine will unpack the diagram and unpack the UDP segment and unpack the DHCP request, and then the DHCP server will reply a DHCP reply back to PCA. So PCA knows what is the current CIDR value, which is 192.168.50/24, and its first router's IP is 50.4.254, and its DNS server is 50.53, and some other information from the DHCP reply, right? Okay, and I would like to mention one important thing is that usually the switch we talk about right here and the switch you buy on the Amazon, on Best Buy, we call this smart switch. Okay, so there will be another layer 2 device which is called hub. Okay, hub is a little different. Okay, it is not smart switch. Okay, so hub, it is still a hub, is it's very similar to switch. Okay, but okay, that is PCD. Okay, and let's simply just write some interface card number right here, EF. Okay, and we connect this hub to this port. Okay. And the difference between smart switch and hop is that if there is a signal, if there is an Ethernet signal, okay, has been reached the hub, okay, the hub will directly broadcast this signal to all the other ports. Okay, and again, if PCC send a frame out, okay, to this direction, right? And the hub will broadcast this frame to all the other 5 ports. Okay, that is the definition of hub because it does broadcasting. Okay, but the smart switch is a little bit different. Okay, it has a switch table, right? Okay, and the switch table looks like this. We have a TTL, time to live, okay, and we have MAC right here and the port right here. That means, okay, when this smart switch receive a layer 2 frame, receive an Ethernet frame, for example, from PCA, okay, and as we know, PCA, its source MAC address is AB, right? So every time when the smart switch receive a layer 2 frame, it check out its source MAC address. So it will have a record, have an entry in its switch table like this. MAC address AB is from port number 2. And for example, PCB, right? The MAC address BC is from port number 3. And for example, AA, MAC AA is right here. Okay, it is right here. Okay, it's from port number 6. Something like that. So next time, if a frame, okay, would like to go to, for example, AB, and this smart switch will only send one copy of this frame to port number 2, and all the other port number 1, 3, 4, 5, 6, 7, 8, and 9 will not broadcast this specific frame because this frame only goes to port number 2 because it goes to MAC address AB. So that is what we call, that is the reason why we call it smart switch. Because hub is a little bit it's not that smart. For any signal it receives from a port, it will be directly broadcasted to all the other ports. So it increases the possibility of collision and it wastes some resources because it is not necessary to do such kind of broadcasting because the broadcasted frame will be dropped by the rest of the receiver, right? But the smart switch only send one copy of the frame to the correct port. So the rest of the port, for example, if port number 6 and port number 2, okay, they're forwarding some Ethernet frame, and simultaneously port number 5 can send a frame to port number 8. As we mentioned before in the in routers design, right? We have a crossbar design, right? In switch, they do have crossbar design as well. Okay, so you can send frames simultaneously because you have a switch table. You can smartly distribute the frame. Okay, so that's the difference between smart switch and hub. And basically, and currently, I don't think you can buy a hub from Best Buy or Amazon because it is an old device and we don't use hub anymore because it is not that efficient than a smart switch. Okay. The next layer 2 device which I like to introduce is bridge. Okay. Bridge is a layer 2 device. Okay. And I think the classic example is access point. Bridge means it needs to bridge two different layer 2 technology. So let's take a look at, for example, right here we have a bridge. Okay, we have an access point right here. It is a bridge. Okay, it is a layer 2 device. And for a bridge, it has more than two different layer 2 technology. So at the one side, we have Ethernet. So we connect Ethernet to here. And on the other side, we have, so right here we have Ethernet, ETH. The other side we have Wi-Fi. So it has a for example, we have a notebook right here, and it has an antenna, so it can connect it to the Wi-Fi. Right? So if a device has more than two different layer 2 technology, okay, in this example, one is Ethernet, the other is Wi-Fi, and the signal will be forwarded, will be relayed between these two different technologies. For example, if a Ethernet frame, okay, comes to here, okay, this bridge will unpack the Ethernet frame, okay, and maybe there is a IP diagram inside, right? And the IP bridge will encapsulate this IP diagram by using Wi-Fi's frame and broadcast the frame at the left-hand side part. Okay, so think about one thing. Since it is a layer 2 device, the difference between an AP and a switch is that switch has only one single layer 2 technology, which is Ethernet in this example. But AP has two different technology, right? Wi-Fi and Ethernet. But essentially, there has no difference because the frame will be broadcast at the Wi-Fi area as well. And there's no any routers right here. So basically, the PCs at the right-hand side and the notebook at the left-hand side. Okay, although those notebook, those laptop are under this AP, but according to a definition, okay, this PC and this notebook, this data, they belongs to the same subnet, and they should use the same subnet ID. Think about one thing: if a notebook, okay, attached to the Wi-Fi, and the notebook will send a DHCP frame, a DHCP packet out, right? The DHCP packet will be broadcasted in the Wi-Fi area, right? But when this interface right here, the AP receives such kind of broadcast DHCP frame, it will further, okay, we use another color, right? It will further send a copy of this frame to the Ethernet side, and the switch will further broadcast this DHCP packet to this DHCP server. So basically, the notebook right here, the laptop right here, it can still get an IP addresses from the DHCP server, no matter it use a Wi-Fi network interface card at the left-hand side. It really doesn't matter because layer 2 device is transparent, so the packet can be forwarded to the entire subnet. Okay, and as mentioned before, switch is very smart. So sometimes only a part of the sometimes the frame will be broadcast in part of the port. Okay, it really depends on the entry in the switch table. Okay, and the other thing I'd like to talk about switch table is that take a look at PCC and PCD. Okay, because PCC and PCD, their frame will be sent to the port number 1 of the smart switch. So these two MAC address will be marked as they comes from port number 1. That is okay. That is okay. Okay, so that is bridge. Okay, but I would like to talk about another access point. Okay, when you go to when you buy an access point, okay, and usually, okay, sometimes the AP said, okay, it is a router mode access point. Okay, so what exactly it means? But as we mentioned before, AP access point, it is a bridge. Bridge is a layer 2 device, but how could a layer 2 device become a router? So basically, it is a very complex box machine. So it has several different devices embedded, okay, in one single box. Okay, so usually it looks like this. Okay, it looks like there should be a router right here, and there's a port right here, and it's connected to a switch, and switch has many different port, and one of the port connected to a access point, and there's an antenna network interface card right here, and from here to here. That is a small world. Okay, and at the right hand side, maybe it connected to port number 8 right here. And again, this small world has a router, has a switch, and maybe it has a DHCP server right here, and maybe it has a DNS server right here, and maybe it runs as an NAT server right here. Okay, so a laptop right here can communicate with each other in this small world. And this small world, usually they have a private IP address, right? Something like this. And at the right hand side, this interface card, this red interface card, okay, we call it WAN port because it connects to the other world, right? But at this WAN port, okay, it is connected to port number 8 at the smart switch, right? And at the smart switch, it can get an IP address from this DHCP server. So in this example, maybe it can I'll be 10. IP address like this. Okay. So if you configure your access point as a bridge, okay, your topology may look like this one, okay, the lower one, and your laptop under your bridge can get the IP address as this get an IP address from the DHCP server, from the outsider DHCP server, because they belong to the same subnet. But if you configure your router, your access point as a router, basically you have an NAT server right here, you have a DHCP server right here, you have a DNS server in this small world. Okay, this small world use a private IP address like 10.10.0.0/16, and your laptop, maybe it will get IP address in this small subnet. Of course, this network topology still works because the traffic will goes to the NT server, and the IP address will become to 192.168.50.22, and then will go to the router, and the router will further change its IP address from 192.168.50.22 to 140, 119, sorry, 119, 1 and 1. So it still works, but you have a small world in your subnet. Okay, so that is two types of layer 2 device bridge. And usually I don't like this word called AP router or AP share machine, something like that, because AP is AP. AP is its definition is it has two different technologies. They can forward frames between two different layer 2 technology. And AP router, actually this is not make sense, okay, unless you know how it works. Okay, at the end I'd like to show you some tables right here. Usually in each table, in each machine, okay, there should be an ARP table, right? Each machine will learns, okay, what is the mapping between IP and MAC. For example, 50.3, 50.4, 50.3 is BC, 50.4 is AB. Okay, every piece, every device in this figure, they will automatically learns the mapping between IP and MAC, right, by using ARP protocol. So you have an ARP table right here in each of your nodes. Okay, and in DNS, okay, it's simpler, right? We have talked about RR record. Still, we have domain and the corresponding IP address. We know which domain is handled by which DNS server, right? And in each in the DHCP server, we have a DHCP client table. Okay, again we have TTL right here, and we have to remember what is the IP address sent by this DHCP server, and what is the corresponding MAC address. Use the IP address. For example, CC is right here. Okay, it get the IP address 53. BC get the IP address, right? And the AB get this IP address. So the DHCP server should maintain a table that each lease, okay, each lease is sent to the client. So corresponding MAC address, corresponding IP address should be recorded in the in a DHCP server, right? And for NAT server, right? Again, we should record what is the source IP address and the port number, right? For example, if there is a TCP session, okay, from 50.3 and the port number should be a random port, AAA, okay, we should specify what is the port used by this NAT server, right? For example, 999. So when the packet return back to the NAT server, it knows which private IP address should be and private IP address and destination port should be used. Okay, so we have NAT table right here. Okay, so I think that is the thing you would like to know, and how we connect those devices together. And that is what we call internetworking. When you want to plan your network, you have to do internetworking. Okay, you have to know which services, which nodes, which device should be used in your network. Okay, and the last one is layer 1. Okay, layer 1 is called repeater. Okay, when you send a signal on a line, okay, the signal, there might be some noise, right? So when the repeater receives the signal, okay, it will transmit the signal, will amplify the signal again and send it to the right hand side. But as you know, signal may have noises. So when you amplify the signal, you amplify the noise as well. So a repeater is not that good, not a very good device. So sometimes you would rather put a layer 2 device between your line. So the layer 2 device will receive the signal and try to decode the signal, okay, and get the original frame. And at the right hand side, it will amplify the signal again, but use the received layer 2 frame to send the signal again, not simply just as the layer 1 device. Layer 1 device does not know anything about frame. It only knows signal. So layer 1 repeater only receive signals and amplify the signal and also amplify the noise. But if you put a layer 2 device right here, the layer 2 device will receive the signal and try to get the original frame, and again to relay the frame to the right hand side using larger power or something like that. Okay, so that is the layer 2, layer 3, layer 1 devices. Okay, so make sure you understand all those things. Make sure you understand why they are connected and how they are connected and how the frames, how the packet are transmitted in your private network and in the internet. Okay, we stop right here and we will come back later.